Welcome to my talk. Thanks for coming. If I can ask you, people in the back, if you can move a little closer to the front, that'd be nice. Well, my name is Gustavo Silva. I'm a kernel engineer. And today we're going to be talking about upstream Linux kernel hardening, and particularly about the work I've been doing to enable this compiler option, Wflex-array-member-not-at-end, in the upstream Linux kernel. My work in the kernel community has always been supported by the Linux Foundation, and over the last couple of years, also by the Alpha Omega project, which is a security initiative under the umbrella of the Linux Foundation that is supported by Microsoft, Google, and AWS. So thanks to those organizations for supporting my work. I'm sorry. OK, so who am I? I've been doing upstream Linux kernel hardening for 9 years now. I'm focused on proactive security. I am a member of the Linux Kernel Self-Protection Project, which is basically the Linux kernel division of the Google open source security team. However, I am not a Google employee. So let me ask you a couple of questions. So how many of you know about this project, the Kernel Self-Protection Project? One person, a couple of people? OK, that's great because, well, now now all of you are going to know about this project. Another thing, how many C programmers do we have in the audience? Almost all of you. OK, how many kernel developers? Oh, basically all of you. OK, that's great. OK, so this is the agenda for today. We're going to start with very basic things about flexible array members. We're going to see what is a flexible array member. Then, of course, we're going to explain what is this compiler option about, what is wrong with having flexible array members in the middle. And then, well, a little bit of a history of how it is that we got to this point where, as you may know already, we have to fix thousands of these warnings in the Linux kernel. And then I'm going to go and explain in detail the different cases I've managed to find out, or I managed to discover that we have to address. And of course, at the end, some conclusions. So a flexible array member, one of the requirements to use a flexible array member is that it should be the last member in any containing structure. So in this case, we have struct flex, and our flexible array member is the last member in this structure. Another important thing to say about flexible structures in particular is that the C standard says that they may not be a member of another structure. So these two points are going to be crucial for the rest of the presentation. So it is important to remember those. Another thing is that usually when we use a flexible structure, we also include as a member a counter member. This counter member, we're going to use this member a runtime to store the total number of items or elements our flexible array member is going to contain at some point. In recent times, we've been annotating flexible array members with the counted by attribute. And by doing so, we gain bounce checking coverage on flexible array members at runtime. So it's not the purpose of this presentation to go into more details about how to use this attribute. I just wanted to show you this because this is how a flexible structure should look like now that we have the counted by attribute. You want to know more about how to use this attribute in particular in C, in the C language in general, and in particular in the kernel. I wrote a blog post the last year where I go into details, and I use, of course, kernel code as examples. And you can check it out if you want to know more about it. OK, this compiler option was developed by Xin Zhao. In GCC, it was released in GCC 14. She's Xin. She's a member of the Kernel Self-Protection Project. She's a great GCC developer Basically, whenever we need to, we need to use a new compiler option to prevent some issues from entering the Linux kernel, we recur to Shin, and we ask her for the implementation of this of any feature in the GCC compiler. If you want to know more about her work, there is a link at the bottom of LWN article where they talk about the different hardening compiler options and attributes Shin has been developed to improve the security of the of NEC code base out there, but in particular for the Linux kernel. Okay, so what is this compiler option about? It basically is going to warn when it detects that we have a flexible array member in the middle of any number of nested structures. So for instance, we have here a stroke flex, and we have our composite structure, and we have this middle object right in the middle of the composite structure. So the compiler is going to complain when it detects this kind of code. A simple fix a simple way to fix this warning would be just merely moving the middle object to the end of the composite structure, and we probably even can change his name. So now instead of middle is the last. We call it the last member, right? And with this simple change, that warning goes away, and the compiler is happy. However, if we have another structure and we have an instance of composite in the middle of this other structure, now that is a problem again, right? So we can quickly see how easy it is that we get into trouble with flexible array members in the middle. So what is wrong? What's really the problem with this type of code? Well, first, let me tell you that a flexible structure in a composite structure is an extension to the language. So as an extension, an instance of a flexible structure can be either the last member in any other structure or not the last member, right? So in this case, this last part is deprecated. We don't want this kind of code in the kernel anymore. And as you might remember, one of the requirements for the use or to use a flexible array member is that this member should be the last member in any containing structure. So it doesn't really make sense that all of a sudden we can declare instances of flexible structure right in the middle of other objects, right? So that's a bit contradictory. So compiler people says they say this, that we need to address this issue. We need to modify our code so we avoid this kind of code, this kind of issues in the Linux kernel. So well, you might already know that we have more than 60,000 of these warnings, and well. Let me tell you just real quick the history of how it is that we got to this point, because at the end of the day, we did this to ourselves, but for a good reason. Okay, it all started back in 2019 when I ran into this piece of code. What I have here, well, what we have here is a zero-length array, and then, well, there is this patch that introduced a new member after this array. So the problem with this is that this zero-length array was being used as a flexible array at runtime. So this is some heap space was being allocated for this object, and at the moment something is written into this array. Well, the RCU head member is going to be corrupted. So that's undefined behavior, and that's wrong. There are a couple of simple fixes for this. One of them would be just merely moving the zero-length array at the end to be the last member of the containing structure again. And that would be enough to fix this problem, because if we allocate some heap space and we write into this object, we are not going to be overriding any other following adjacent member because, well, it doesn't exist. However, a better solution for this is to, after moving the subject at the end of the structure, we could also transform the zero-length array into a proper C99 flexible array member. So if we do this, now if someone else comes and try to introduce another member after the C99 flexible array member, now the compiler is going to complain. Because for the compiler, this is a hard error. So by merely transforming our zero-length array into a flexible array member, we are, we are getting the help of the compiler, right, to keep these kinds of issues out of the Linux kernel. So this was an 8-year-old bug. I discovered this back in 2019, but it was introduced in 2011. So when I was talking about this problem with Case Cook, which is the leader of the Linux Kernel Self-Protection Project, he was like, well, probably we need to go and take a look across the whole kernel tree and try to see if there are more instances of this problem. And probably we need to find the different ways people have been implementing flexible arrays and transform those into C99 flexible array members, right? And that actually was the kickoff of the flexible array transformations, the effort of transforming all those instances of fake flexible arrays into proper C99 flexible array members. So that's, this started back in 2019. So yeah, we went and looked for, I mean, well, before C99, people would use one-element arrays, or as I just shown to you, zero-length arrays, right? So transforming these arrays took us about 5 years. It might well be the case that today we could have a couple of standards out there under certain strange configuration, but this work is basically done. So then, yeah, we have here an example of a fake flexible array as a one-element array and of a fake flexible array as a zero-length array, right? And well, then we discovered some issues in the 45 version of main copy while we were doing this work of transforming these fake flexible arrays. We discovered that the compiler was actually considering any trailing array as a potential flexible array. So what is a trailing array? Well, a trailing array is merely an array that is going to be the last member of any structure, right? So in the case of a one-element array and a zero-length array, those are trailing arrays. The problem we found was that even when people were implementing a trailing array of, let's say, of a concrete size of 10 elements of size integer, for the compiler, that was not a fixed size array. That was actually a flexible array member. And the problem with that is that when we were using important building compiler functions like building object size or building dynamic object size to get the size of those trailing arrays, and with that, well, actually adding bounds checking to these objects, well, the compiler just couldn't help us on this in this case because it was returning these building compiler functions. They were returning -1, which means that they didn't know how big this object was. When in reality, at build time, these objects they had a concrete size, right? So that was really confusing, and well. Compiler people needed to, well, we asked them to implement the strict flex arrays compiler option. So with this, by enabling this compiler option in mainline, now we removed that ambiguity that we had of having different ways to declare a flexible array. So by enabling strict flex arrays with a level value of 3, which is the strictest value, you can have this. You can use for this compiler option. Now the compiler is going to interpret any, well, it's going to actually evaluate any trailing array. And in the case that that trailing array is not an actual C99 flexible array member, then that trailing array is going to be treated as an object of a concrete size. So now building object size and building dynamic object size are going to return the proper size of that object, right? So the ambiguity was fixed by enabling this compiler option in mainline and by completing the work of flexible array transformations. So then in recent times, we had, compiler people implemented the counted by attribute. And well, we are adopting this attribute in the Linux kernel. We've been annotating as many instances of a flexible array member as possible with this attribute. And well, this is work in progress. It's not the purpose of this presentation, again, to go into every single detail about the history of how it is that we got to this point, because what I just described here is 6 years of work, right? And if you want to know the full story, there's a link to a presentation I gave early this year at the University of Adelaide. This was a presentation for master and PhD students, and this is an 80-minute long presentation, so you can take a look, and you're going to see all of the details of the last couple of slides, right? Okay, so now we have thousands of warnings to address, and at some point I got curious, and I wanted to know how many of these warnings we had before even starting the work of flexible array transformations. And it turns out that in 2019 we have about 8,000 of these warnings. So now, after 6 years of hard work hardening the Linux kernel, we have 60,000 of these warnings, right? So, I mean, this only means that now we know the problems that we didn't know we had, right? The good news in this case is that about 1% of that total amount of warnings are unique issues to address, right? But still, there are hundreds of issues to fix, to address. Okay, now I'm going to go into the different cases. I mean, I classified these hundreds of warnings into at least 4 different categories of issues. So I'm going to go into the description of each one of them, and we're going to see how I am fixing those. So the most simple scenario is when the flexible array member is never actually used. So this means that I went and took a look at the code, and I couldn't find any instance where heap space was being allocated for this flexible array. So in that case, the solution is quite simple. We just need to remove that array, right? And I submitted this patch, and this is just part of the patch. In reality, I removed 4 instances of flexible arrays that were not being used. And with that, I managed to fix 100 warnings. And I was really happy because I was like, oh my God, this is going to be easy peasy, right? Yeah, but no. Okay, case number 2 is when the flexible array member is not accessed through the composite structure. There might be instances of code where they are allocating space for the flexible array, and they are using this flexible array as a variable length object at runtime, but this array is never actually accessed through a composite structure, right? The composite structure, well, the other objects, the other members in the flexible structure might be accessed, but never the flexible array. So there are a couple of potential solutions for this case. One of them is, well, we could just have like a new structure where we can include the header part of the flexible structure, right? So in this case, flex header would be that new structure. The problem with this is that we would have 2 separate structures, and basically the code would be identical, right? As you can see, I mean, we are duplicating code. So that is not really great. However, if we do this, we can just change the type of the middle object from a flexible structure to now the new type, which is the header. And with that, well, the warning is going to go away, and life is beautiful, right? But as I have said, that is not really a good solution for this. We are duplicating code, and is not the best solution. So now probably some of you might be thinking, okay, but what if instead of duplicating code, why don't we replace the header members in the flexible structure with an instance of struct flex header, right? Like in this case. Right? Here. The problem with this is that the counter that we use in the counter by attribute cannot be in an anonymous structure. So this is really not possible yet. Compiler people, they are working to add this feature to enhance the counter by attribute so that the compilers can support this feature because, I mean, we really need it. But today, this is not possible, unfortunately. Okay, another solution for this, another way in which we can fix this kind of problems is by using some helpers through group. How many of you know about through group or have ever used this helper? No one. Okay, that's perfect. I'm going to get into the details of this. Okay, the way in which we would solve this problem is we would use through group to enclose the header part of the flexible structure. And then we are going to create a new tag that is going to be used inside through group to create a new struct type, actually. So in this case, flex header is going to be that tag. And then we replace, we change the type of the middle object from struct flex to struct flex header. And with that, the issue goes away because we are creating a new type without the flexible array member, right? So that's a potential solution. And this is how, this is the magic of struct group. In struct group, we have a union, and well, we have a couple structures. One of them is an anonymous structure. With this anonymous structure, what we are getting is that we can access those members that we just enclosed directly without having to use a new identifier or without having to use, or having to do what we have to do if we would instead write a substructure, right? So we can go directly and access them. And then we create a tag structure, which is going to be the structure that creates the new type, the new struct type. And that tag structure contains an identifier for the whole group. So these have the advantage that now we can gain bounds checking on this group of members. And well, now this couple of blocks of code, they are equivalent. Because, as I was saying, if we use through group, we can access the members directly. We don't have to use the header identifier, but if we want to use it, we can use it. So this is like a versatile header, a versatile helper in this case. And well, I've been fixing some issues using this through group helper. And well, this is an example, of course. Here, I am enclosing the header part of the flexible structure. I'm leaving the payload out of the equation. And then in the composite structure, I'm just changing the type of the objects. And that's enough to fix that issue, right? Because, I mean, the composite structure has no visibility into the flexible array member anymore. Okay, now this is going to get more interesting. This is probably the most complicated case. I found out that some people, well, they were implementing this kind of code construct where they had an instance of a flexible structure, and then immediately after that instance, they would have a fixed size array. But what's interesting here is that the type of this fixed size array, the element type of this fixed size array, is the same element type of the flexible structure, which means that they are creating an implicit union. People, they wanted to have the address of the flexible structure to be the same of the address of the fixed size array, and with that they can iterate over the flexible array member, having enough space in the fixed size array, right? So this was, of course, for Wflex-array-member-not-at-end, for this compiler option, this is a false positive, of course. I mean, this is a warning, but it's a false positive because this is intentional. However, this is really prone to error, so we shouldn't really do this kind of things, because if we change something in composite struct, probably the alignment of the whole structure is going to change. So the addresses of those arrays are not going to be the same, right, at some point. So whenever I see this kind of code, I go and take a look if they are also using a static assert at the end of the composite structure, just to make sure that the offset of the flexible array is equals to the address of the fixed size array. In that case, that would be correct. But well, the cases I've seen so far, they are not using a static assert. So yeah, at any moment this can change, and well, an issue can be introduced, right? So yeah, this is what I just said. I mean, the alignment of the composite structure might change, and well, a static assert is necessary. So, however, we can fix this kind of problems also using struct group. In this case, again, I am enclosing the header part of the flexible structure in struct group, and then I am changing the type of the object, right? And with that warning goes away. However, in this case, what I discovered is that the rest of the code was actually trying to access the flexible array member, which is not possible anymore because the composite structure has lost visibility into that array, right? So when that is the case, we can actually use container of. And well, this is what the code was trying to do. The code was trying to access the flexible array member, but that flexible array member cannot be accessed anymore via this header object, right? This header identifier. So in that case, we can use container of. So we can just we can create a new pointer variable of the type of the flexible structure, and I mean we have everything we need. We have the arguments we need to pass to container of, so we can retrieve a pointer to the flexible array member. This might look a little bit like magic, but yeah, this is something that we've been doing. I've been doing. I mean, because I mean, if someone is to blame, it's me. And yeah, so this is another way in which, or this is probably the solution, the best solution up to that point, up to the point where I started fixing these kinds of problems. That was the best possible solution I could come up with. So yeah, we would use in this way we get a pointer to the flexible structure, and now we can actually access the flexible array member, right? And well, the case number 4 is exactly the same as case number 3. Is the same. We have an implicit union, but in this case is on stack. So we have code like this. We have our flexible structure, and we have our fixed size array of the same element type of the flexible array member. So it's basically the same problem. So to fix this, we have a couple other helpers that we can use. And we will fix this with the define Wflex helper. This helper was created precisely when we wanted to allocate on stack certain number of members for the flexible array. Without, I mean, they really didn't want to allocate heap space, and with this helper we can do this on stack, right? So it's fairly simple how we would use this helper. The first argument, well, is the type of the flexible structure. The second argument is going to be an identifier for a pointer. So this helper creates a pointer. So that means that we need to modify the rest of the code, right? We need to do a lot of changes to accommodate for that change to a pointer variable. And in this case, the original code was using just a couple of objects. And that is the reason why we are saying this helper that we need to allocate 2 elements for that flexible array. And here are some code examples. If you are curious about this, or you want to know, you want to see exactly how all the implications of using these helpers, you can take a look at these commit IDs. And well, you can see how I've been using declare flex and declare Wflex. Okay, case number 4, but let's say a second part. A second part is when we have, again, this is on stack, but instead of having objects of the same element type as the flexible array member, we can have any type of object after an instance of a flexible structure. So in this case, as you can see, the type of the element type of our flexible array member is integer. The size is going to be 1 byte. But the members after the flexible structure, well, we have a union and we have a couple of structures, right? So in this case, we could use define Wflex, and I used it to fix this kind of issue. And however, things start to get a little bit weird. I have to, instead of passing just a literal, asking the helper to create, to allocate space for a certain number of elements, now I have to come up with a bigger, with the size of the bigger object in the union, right? So to accommodate for that space that we need. So this is a way in which we can fix this. I actually submitted a patch for this, and it was applied. I wasn't really happy about this because to me this was like abusing defined raw flex, because it was not created for this purpose. So the reason for that is that what happens if we run into this kind of code that instead of having a couple of members in a union, now we have 3 or more. Right? So probably we would need to use a couple of, we would need to call max 2 times as the last argument in the define raw flex helper. So yeah, I didn't like this. Actually, the implementation of the patch I wrote was this. I mean, I took the union outside even of the function. I created a new type for this union, and then in the define raw flex part, I just applied the size of operator to that union type, and then we're going to get the size that we need for that union, right? And yeah, I submitted this, and then I got this reply from the maintainer. Yeah, he was actually proposing me to use to do what I didn't want to do in the first place, right? He wanted me to use a couple of calls to the max helper, and yeah, because I mean he didn't want to have a definition of the union outside of the function, so. Yeah, to me, again, this is an abuse of the define raw flex helper. I'm actually writing a blog post where I'm going to describe, or I'm describing different patches that I have submitted, because at the end of the day, because I had to actually address some issues like this using this helper, because I didn't know better at the time. And I'm going to explain. I'm writing this blog post as a sort of like an apology for the people that took those patches, but I'm planning to correct that. So yeah, define raw flex was not created for this kind of scenario. So I was thinking probably we need a new helper for this. And then I remember that, I mean, we've created all sorts of helpers to address the problem of flexible array transformations and to address the problem of flexible arrays in the middle. So we had, I remember that when I was doing the work of, when we were doing the work of flexible array transformations, I used this declare flex array helper. And what this helper does is basically it allows for a flexible array member in a union, which is actually not allowed by the C standard, because a flexible array member may only be a member of a structure, right? But in this case, we needed to find a way to declare a flexible array member in a union, because we run into a lot of instances like this that people, they needed to use a flexible array, but they also wanted to use other type, right? And they wanted they needed to use a union because they wanted to iterate either over the flexible array, or they just wanted to use, in this case, the can message object directly, right? So we needed to figure that out, and well, we came up with the idea of this helper. I'm not going to go into the internals of this helper, but what I got from here is that we could actually have a flexible array member together with other members. And the compiler is not going to complain as long as it sees this flexible array as the last member in a union, right? And then I was like, well, probably if I manage to transform those structures that are using instances of a flexible structure and that contain other following adjacent members, if I manage to transform that structure in a union, with that simple change, the compiler is going to see the flexible structure as the last member, and thus the flexible array member in that structure is going to be the last member, and the compiler is not going to complain. So I managed to come up with this idea of a new helper, in this case, the trailing overlap helper. So as you can see, we have a union. And in the union, we have a couple of objects. We have, in this case, type and name. Type is the type of our flexible structure, and name, of course, is going to be the identifier for that object. And then the second member is going to be an anonymous structure that is going to contain the members of the original implementation of the original structure. And by doing this trick of including in this anonymous structure a placeholder, basically a padding that is not going to be used, but that displaces the members so that the offset of the flexible array member is exactly the same as the first member in that group of members. With that, we actually are fixing those warnings, right? Because I started to think about this in terms of the memory layout. So I had to go like an abstraction layer before and a previous abstraction layer and figure this out in terms of memory addresses, right? I mean, what is the intention of developers here? I mean, okay, they just want to be able to iterate over the flexible array, but they also want to iterate over these objects after the flexible array. Which is, I mean, in reality, it's not after, it's at the same memory address. So with this simple trick, with this simple helper, I managed to fix this kind of problems in this way. So I went from this patch to now implementing something like this. And it's quite straightforward, it's quite simple. We maintain the memory layout and the memory layout. The memory layout is not altered in any way. However, I have to say that the last couple of weeks, I was taking a second look at this, and probably we need to also use a static assert. So to ensure that the alignment between the offset of the flexible array member is always the same as the start address of the first element for instance, in this union, right? So probably I need to do that. Okay, so I sent a patch for that, and well, using this helper is superior to the technique of using stru group, particularly when we have to use container of, because that is a bit of a shenanigan. So this is the code I showed to you as an example for case number 3. This is part of the original patch. I had to change a lot of other things in order to accommodate for that, for the use of container of and the use of stru group. So that code, that big patch, turned into this with this new helper. That's everything I need to modify. That's everything I need to change. Well, that's all I need to change. And with this simple change, those warnings go away. So this is basically the evolution of the approaches I've been following to fix this issue and to manage to have this compiler option enabled in the upstream Linux kernel. So I went from okay, having a separate structure. I mean, I never really actually proposed this. However, some maintainers, they wanted to use this approach, and well, I had to do it. And then, well, I figured the solution by using stru group and container of. Then I started using the define flex helpers. Then I started abusing those helpers because I didn't know better at the time. Then I came up with the idea of this new helper, right? And this is what I am using in recent times. This is an example of, this is an interesting patch. In this patch, you can see how all these different approaches, because I started the version number 1, I used stru group, then I changed in version number 2 to use define reflex, then I implemented the open-coded version of the trailing overlap helper, then I ended up using the trailing overlap helper, and the last version, well, I just needed to fix a couple of things. But if you take a look at this patch, you are going to basically see this whole talk in one patch, right? So some conclusions. Yeah, originally I thought this was the best idea out there, but well, we can avoid a lot of trouble if we just go with trailing overlap. However, in some cases we still need to use stru group, but that is going to be only when we don't need to use container of. So yeah, for implicit unions on stack, we can use either the declare flex helper or the declare rock flex helper. And well, for unions or implicit unions where the objects are of a different type of the flexible array element, or the type of the element type of the flexible array, we can use trailing overlap. So yeah, so right now I want to think that I have a clear idea, a clear strategy on how to complete this work. And dozens of patches are in mainline right now. I managed to take that number for 650 down to 200 of these unique issues. So that accounts for about 66% of this problem already completed. And that's it. Thank you.